Hi everyone, welcome to my video presentation. In this video, we're going to talk about the shortest path. Shortest paths. So what is shortest paths? It's finding a path between two vertices such that the sum of the weights of the edges in the path is minimum. So this problem is very famous in graph theory, also as famous in computer science and transportation and communication. I bet you have come across this when you calculate the path between, for example, two cities. You want to find a shortest path between those two cities using different roads, and basically when you use a GPS, it uses that algorithm to calculate the shortest path between two points, and basically the shortest path problem. It is finding a path between two vertices such the sum of the weights and the edges in the path is minimum. Example can represent time between each city, taking the particular road or distance between those two cities, taking that particular road. And let's say you want to find the path between C and G, meaning you want to find a path such that when I sum the weights of the edges. So let me give you an example. Let's say we have a graph like this. As you can see it here, we have a weighted graph. I have assigned a value to each edge too. So, for example, edge that connect to C to B is weighted 3. Edge that connect to C to D is where 4, and so forth. The vertices here can represent cities and the weights. For example, can represent time between each city taking the particular road, or distance between those two cities taking that particular road. And let's say I want to find the path between C and G, meaning I want to find a path such that when I sum the weights of the edges, I get the minimum number. So I can go like this. For example, if I go like the sum of the edges will be 4 plus 4, 8 plus 1, it will be 9. If I go like this, for example, it will be 3 plus 2, 5 plus 4, 9 plus 1, it will be 10. Or I can go like this. I can go from C to A to B to D to E to G. As you can see it in this particular path, the total sum of the weights of the edges in the path will 2 plus 1, 3 plus 2, 5 plus 4, 9 plus 1, it will be 10. So between all the paths that I have taken to go from C to G, this path is the shortest because that sum of the edges will be 9, and the rest of the path that I took have the total sum of 10. Therefore, the shortest path between C to G is a path that goes from C to D to E to G, and that is basically the idea of the shortest path problem. We have several types of shortest path problems. We have single pair shortest path problem, single source shortest path problem, single destination shortest path problem, and we have all pair shortest path problem. The single pair shortest path problem is finding a path between a single pair or vertices. So let's say this is our graph. A single pair shortest path problem will be finding the shortest path between C and F, or between A and G. Basically, you take a single pair of vertices or points and you will find the shortest path between. However, single source shortest path problem is pinpointing a vertex to be your source and then finding the shortest path from your source to all other vertices. So here, our source is C. I will find the shortest path between C and A, C and B, C and D, C and A, C and F, and C and G. So the path in the single source shortest path problem will originate from the source and it will head to the rest of the vertices. Then next is we have single destination shortest path problem, which is opposite to the single source shortest path problem. And basically here you will have a destination. For example, let's say C, and then you'll find the shortest path from all other vertices to C in single source shortest path problem. We found the shortest path from the source for the rest of the vertices. However, in single destination shortest path problem, we find the shortest path from the rest of the vertices to our destination. Here, our destination is C, so the path is single destination shortest path problem will originate from the other vertices to your destination, in our case is. Finally, we have all pair shortest path problem, which is finding the shortest path between all the vertices. So let's say I will find the shortest path between A and C, B and E, A and D, A and E and and F and G. Then I will find the shortest path between B and C, B and A, B and D, B and E, B and F, and B and J. Then I will find the shortest path between D and B, D and C, D and E, D and F, and D and G, and so forth, until I find the shortest path between all my vertices. So we have single pair shortest path problem, which is finding the shortest path between a single pair or vertices. We have single source shortest path problem, which is dedicating a vertex to be your source, and then you'll find the shortest path from your source to all the other vertices. We have single destination shortest path problem, which is finding the shortest path from all the vertices to one single destination. And finally, we have all pairs shortest path problem, which is finding the shortest path between all your vertices. So now we know what is the shortest path and the types of shortest path problem.